in this video I'm going to talk about how to develop a PDF file from scratch. So we'll start with the introduction about the topic. So to build a PDF file, we need to understand that the PDF file is made up of objects. The building block of a PDF is objects. So if you don't understand objects well, then we cannot build a PDF. So the first part of the video, the introduction part, is totally comprised of understanding about the objects, the PDF objects. So we'll start off by the basic structure of how a PDF object looks like. So this is how a PDF object looks like. The starting is this one, the 10 obj. So let me explain what this means. The 1 here is the ID of the object file, and 0 is the generation, and obj means it's an object file. So the PDF, when the software renders the PDF data, the PDF file, it understands that this one is the beginning of an object. So the ID of an object is the first one, this one is the ID, and the second one is the generation of the PDF object. The generation is kind of like an outdated concept for the modern PDFs. The generation was basically used to have a version check, but nowadays it is not used anymore. So most often you will encounter a 0 in this generation part. And the next part is that the arrow signs, which indicates the starting point of an object container. Means this is actually called a dictionary. I'll talk about it later in the part of the video, but this is how the structure of PDF objects looks like. So it starts with that arrow sign, and inside it goes some data, and then the arrow sign is closed, and after that we have the end obj, which marks the end of the object file. So the object file ranges from the obj to the end obj, and that's all. So the next structure that which is second common is the stream part, the stream data, the stream object. So you can actually in the previous slide you can say that there are two things like the object and end object, and we also have that arrow sign. So we could actually strip out the arrow sign, but I mean imply the same thing, like the object means the start, again the arrow sign means the start of the object. So we have the repeating meaning part in this obj structure. So actually they are not repeating, they are actually, in case of stream objects, we need both of them. We need the object is the main you can say the parent, the holder, and inside it there is this arrow sign which indicates the length of the stream, and there is this stream, the end stream. So the main thing is that we need both of them. We need obj and obj, and then inside the obj we need this arrow sign to indicate the starting point of the data inside them. The starting arrow sign, then the ending arrow sign. Then after that, if it is a stream object, then we will also have that stream which marks the beginning of a stream data, and the end stream marks the ending of the stream data, and the stream data is sandwiched between the stream and the end stream. So that's the second structure, means the structure for stream object of PDF. So coming to the next point is the data inside the PDF object. Actually the type of PDF object is classified by the contents inside. Let me go to the next slide. Is the object types are mainly three types: the integer, the real, and string objects. So we can say that the integer object is the basic number, like 40, or means anything. It could be 10, 20, 30, 40, any number. The whole number is integer. It could be positive or negative, it could be 100, it could be plus 50, it could be minus 50. The sign is is optional. We could include the positive sign if you want to, or we could also not mention any sign, and it would be by default a positive value. So the next object type, the integer object application means, so where we can apply that integer object type. We can apply it to indicate the number of pages in a PDF. For example, here we have mentioned that the total pages is 40. There could be times like that we have to mention the pages, and we can use integer to do the same. And we could also use reference object to as an integer, like in this example we have not used that 40 directly, but referred it as an object with id 2 generation 0, which is in the previous slide. This one, the id 2 generation 0 object has the value 40. So when we write it like that, it would get replaced with 40 because it is a referenced object. At the end, it is provided that the r is provided, which means it's a reference object, reference to id 2 and generation 0. Now moving to the application. Actually, the main another application of that one is real means the real life application, you can say. Or okay, let's call it an example. The stream requires the length of the data, means the bytes inside the stream. We have to provide that information to a stream object. So say for example we have a stream data of 300 bytes. We have to write it like that, length 300. So this 300 is an integer, so it's a example of the integer object. So the next type of object is the real objects. So real objects is nothing but a decimal object, like 34.156 minus 50.54 plus 30.0. So like the integer have sign optional. Like if it is a positive value, then the sign is optional, but if it is a negative value, you have to mention the negative sign. So in case of real object, it's the same thing. If it is a positive real number, then you have to mention the positive. If it is a positive real number, then the sign, you can mention the positive sign, or you can ignore the positive sign. But if it is a negative real number, you have to mention the negative sign. It's a requirement. So the next object is the string object. String object can have different forms, like the ASCII string, the binary string, the text, and the date. So to write an ASCII string, you can simply use the round brackets, as in the example. The red color font has a round bracket, and inside it is written the coding font. So that red color font is a string object. So inside the round bracket, everything is considered as a string. So even if you include a round bracket inside a round bracket, that round bracket would be considered a string. Anything that goes inside is a string inside the round bracket. So that's one example of the ASCII, and this is another example of the binary data. So inside a binary data, if you have to write any binary data, then you have to give the angular bracket. You have to write it inside an angular bracket, and the data format is a hexadecimal number. So this is an example of the binary data. And to write text data, we will use the same binary data format, but we will also include the BOM, or byte order mark, to indicate whether it is a UTF-8 or UTF-16 or UTF-32, or what the text encoding system is. So this one is for encoded text. If you have to write encoded text, then we have to use it with BOM. Now the next important type of string is the date format. If we have to mention a date, then we have to include it in this format. We have to apply a t with colon, and then the format is YYY MM SSOHH comma mm. So let me explain what is going on here. The YYY is the year, the MM is the month, and the DD is the date, the day of the month, and HH is hours, MM is minutes, and SS is seconds. Now the hours is in actually 24-hour format, and the OHHMM in the last section actually indicates the GMT adjustment. So O is the actually sign, whether it is plus or minus. So as I am recording from India, so for Indian Standard Time it is considered as plus 5 hour 30 minutes from the GMT. So I have mentioned plus 05 comma 30. So this is the GMT adjustment. So an example of the date is like that: 2022, which is the year; 12, which is the month of December 10th, and then 08 means 8 a.m. and 25 means 8:25 a.m. and 30 seconds. So this is how a date format should be written as a PDF object. And we have the null objects. The null object is actually rare in PDF, but it's there. The system is there. You can, if you wish to, if you feel it necessary to write a null object, then it's there. You can write it, but in practice, null object is very rare to find, at least in modern PDF. And we also have the Boolean object, and it's simple: true, false, all that. And we have the name object. In the previous examples, you can see that there is a slash, forward slash with some name. This type of thing has a special meaning to it. I'll discuss about those in my next videos, but for now just understand that they have special meaning to them, and they start with the forward slash. That's all. They are called name objects. And then we have array objects. Array is just a collection of objects. That's all. They are separated with a white space, a space bar, and we can have any type of objects inside the array. Array is actually homogeneous. It doesn't have to be of the same thing. Like if we use integer, then everything has to be integer. This is not the case. There is integer, there could be a string inside, there could be real object inside, Boolean object. Array is kind of like a mix-up of object could exist. There is no such thing, no such restriction that there has to be only one. Then we have the dictionary objects. So dictionary objects is kind of like the arrow sign part. So as you can see, the font in the red colored font, we have the arrow sign, starting arrow sign and ending arrow sign. Anything inside this one is the dictionary, means including that arrow sign, it's called the dictionary object. The whole thing is called dictionary object. The arrow sign part is considered as dictionary. So it can have multiple name and value pair, like font, and then we have an array of F1, F2, like that. And then we also have the name tree. The name tree object is, instead of the name and value pair, we have string and value pair. Like the apple is a string and we have a value of another string. Name1 is a string and we have a value of another string. Sorry, name1 is a string, we have a integer value. The name2 is a string, we have a name value, and zebra is a string and we have a dictionary value. So whatever may be the value, but the key is always a string. So that's a name tree. And next we have the number tree. It's similar to the string tree, but instead it has numbers. And one thing about the name tree is that they are all in alphabetic order, means they are sorted in ascending order, alphabetically ascending order, like A, O, and Z. They has to be sorted. Okay. And similarly the number has to be sorted. The key part of the number has to be sorted in ascending order, and that's how the number tree object is formatted. Next we have the stream object, which we have already covered before. The basic idea about stream object is that we can write any images or anything, encoded text or any objects inside with the help of stream objects. The stream object requires the length. The length is a mandatory in case of stream objects. And as you can see in the screen, this is the basic structure of a stream object. The stream data is actually a binary data. It don't get misleaded by this round bracket stream data. Means it is not a string. Okay, it's actually, I have not written the actual stream data there. When we'll in the next coming videos we'll do the actual stream data, so then you will get a clear understanding how to write stream data and all. So next we have the indirect object. So it's the reference objects that I have also covered this one previously, but let's talk more about it. As we can see here that we have a integer object with ID 1 and generation 0, and the value is 256. So 256 is just an integer object. Okay, now we have to mention the length of the stream data. So to mention the length of the stream data, we have indirectly referred as 1 0, so it will fetch the data from there. So the length would be parsed as 256. The length is 256. So it's the 10R is an indirect object because it is referring to some object, some other object. So that's how indirect objects work. So that's all for this video. I will cover in the next video I will cover how to actually build the PDF using Python code. I will write the code in Python and will show you how you can actually build a working PDF to begin with. So till then, see you.